Good morning. This week we're going to start on the section on life cycle analysis or life cycle assessment. I know we just completed the exams. I hope you had a good experience with those exams and that you were able to learn something when you were taking them. You're going to see that we're transitioning really into life cycle analysis. We've been kind of talking about it when we talked about sustainability and about ecosystems. And life cycle analysis is really a tool to assess the environmental impacts of different processes and procedures and practices on the environment. And the thing that I like to consider, that I like to think about when I talk about life cycle analysis is it's a way of measuring the leakages of a substance from the cradle, from that elemental form, from where it was, to the grave, which is when we finally get rid of that product. So in between there, we talk about a lot of different stages. And so one thing that they'll talk about, as I said, is they'll talk about cradle to cradle. And so that idea we talked about recycling would be a cradle to cradle. So I start with an elemental substance, I convert it into a product, and I'm bringing it back so I can recycle it and make it back through the system. That would be cradle to cradle. Yeah, I can talk about cradle to gate, and when we talk about gate, we're talking about some point of that production process, usually before it gets to the consumer. But there's lots of potential there for gate to gate, in between processes, where I make one substance, that substance is used in the production to make another product, that product is added on to something else, and so you could do any one of those gate to gate. But usually what we're talking about when we say cradle to gate is taking that element and then forming that product. And so then the gate to grave would be the idea that from the time that leaves, what happens to it as the product gets used and then eliminated. So that's really what we're talking about, and the idea is to identify where those leakages occur and how important are those leakages, how much energy are we losing, how much how much stuff are we losing, because as we talked about before, as those things leak out of the system, out of that cycle, then the rate at which you're losing that could make that non-sustainable. Okay, so it's a matter of, if the demand over a period of time that you're considering is greater than the supply, given that you have that leakage, then you have a non-sustainable practice. So that's the kind of idea. As you go through as we go through the life cycle analysis, I want you to keep that big picture in mind, and we'll be giving you lots of readings. There's lots of literature on studies on life cycle analysis. Typically, you'll see that it's rarely cradle to cradle, but it's more often cradle to gate, or gate to grave. So when we talk about bioenergy, I think it's important for us specifically to talk about cradle to cradle, in as much as we're talking about an element or a stock resource like oil, and how we're going to use that and bring it back. And as you saw in an ecosystem, there has to be that exchange of nutrients, so that, or change of elements, so that you're using and giving back, so that system's able to cycle. Now that isn't to say that some of that is lost, but the idea is that the stuff that you're getting in, say from the sunlight, is about equal to what's being lost. And so the flow of resources within the earth is staying about the same. So as we go through that, you're going to be picking an industry, you're going to be picking a product, you're going to be looking at that, and we'll be going through that. Now there's a couple of other tools that we use, and one of them is probably the one that's most on the upswing, let's say. It's the thing that's coming to be more often used, because in the economic literature we often talk about an economy-wide impact, and that is we want to know, let's say, if given the drought that we have, and we have less livestock that are out there, we want to know what's the economic impact of that. Well, we're not only interested in the fact that we've lost beef production, but we've lost transportation because we're not moving those cattle. We've lost employment at the sale yards because we're not having that number of cattle flow through there any longer. We're not having as many processing jobs anymore, etc. So all those things, kind of like a production function. What does it take to produce a pound of meat, and what are all those items? Every time you don't produce an animal, you get all those. And the same thing is true as we build in this life cycle analysis into what's called an input-output model. So every one of those components that we have in that production function has some impact on the environment, whether it's the actual cattle production itself, the transportation of the cattle, the processing of the cattle, the labor, the person that's making money off of that labor is spending that money on other goods. And so all of those things are captured in the environmental impacts of all that is being captured in that one moment of that 1 pound of beef production. So that's kind of an overview of that input-output model. We'll be trying to take a look at a small project of that. We've only just received that component of an input-output model here at Oklahoma State. That's a real new science, but it's something that everybody's moving to, that now instead of just doing an economic input-output assessment or an economy-wide assessment, we'll also be doing that economy-wide assessment with the environmental impacts. So that's kind of a big picture of LCA. I hope you'll enjoy this. It's a really interesting area. It's a really different way to think, and that's the whole point of life cycle analysis, especially for scientists, is to try to get them to think that when they're manufacturing, when they're coming up with ideas for new products, to try to think about how to make sure that that product can be recycled and brought back in so there's less leakage out of the system. Okay, I hope you have a great week.